So in this short webinar, we're going to discuss about what's new with Allplan 2020 with a special focus on engineering features. I hope it's okay. The screen is working. Yes. So there have been many innovations, and as far as you know, just to have a clear picture, there are multiple packages within Allplan. So there's a focus for designing buildings, and this is the engineering building, which can be as packaging squared or cube, depending on the features implemented. Then there's the civil, which focuses on non-typical structures that cannot be made with architectural elements, and usually rely on 3D modeling. But the idea is here you shouldn't complicate life. You should always go through the building, because building has most features for engineering. You can also do with engineering building any type of bridge structure and so on. And finally, just to clear things, because when you're installing Allplan 2020, you get additional shortcut with Allplan Bridge. Allplan Bridge is a separate software that is somehow integrated with Allplan. So it allows you to make a mathematical parametric bridge that links with Allplan. So the idea of a parametric bridge is the fact that you use mathematical functions to establish the shape of a cross section, the variation along it. So it really helps the modifications during the design phase or adapting a bridge to another. However, you need a mathematical thinking, and the initial building of the bridge takes more and more time. However, the team that is developing Allplan Bridge is very passionate, and they went very fast and very far. They made this 4D parametric, meaning that even if you are within a drawing software, as is Allplan, within this plugin Allplan Bridge, you can simulate the phases of construction, and also they implemented analysis, not only determine the cross-section capacities, but also the forces, and now they're working on the capacity of the elements. So if at any point you'd like to get within the bridge area, this is a nice solution that improves Allplan with this parametric model. So this separate license, but when you install, you get a 30 days trial also for bridge. Now, the idea of the novelties within Allplan 2020 was, of course, to solve designers' problem, which are the time pressure, complexity of structures, processes, and so on. And they made some processes, some workflows that have been improved, and brought a lot of new features as well. So just simple things like the grid system, which was always a challenge, is now, I'll also open now Allplan just to show a bit clearly. Before there was this grid system which was not that friendly, but the most challenging part was the fact that all grids were orthogonal. Maybe for precast that is not an issue. However, if you were doing a stadium or portion where you needed skewed axis, a skewed grid system, that could lead to some challenges. And having a 2D approach is not always the best solution. So the idea is that they implemented a new grid system, and but I like to let you know that also the old one is available. So the new grid system is can be found in the basic tools, and it's very friendly. It's called Axis Grid, and what is friendly about it is the fact that it's very parametric, so it's very intuitive to change spans, to change values of the spans, or if you want different values, you can just type them with dashes, and it's very fast the way you create, and very interactive because you have everything within a palette. This was also a bit available in the 2019 version. However, the problem and the frustration came around the labels. So before you could only establish what kind of label you want, either A, B, 1, 2, or a series. But now you can set up custom text, which means that you'll be able to change, to make prime grids or make any adjustments of the labels themselves. So you can just type here something like B prime, and that's it. You have it here. And if you double click on it, and you can also make any changes here. So if you want to add an intermediate grid, that's no issue in any direction. Also, you can remove grids, and you can also rotate grids. And the idea, okay, the rotation is within the border, and you can also impose a certain angle. Now, just an advice, because when you're going to switch to 2020, you might be using also the old associative system. So this is something I haven't talked at all during the initial training we had. Um, the first, when you go to views and section, the first part, views and section, I called them before architectural views and section, but now things have changed. So now it's not only architectural views and sections, but this is called unified views and section. And what do these unified views and section allow you to do is to create, to detail. You can detail any type of item. So you can detail reinforcement, architectural elements, 3D objects, and they use a different technology. So they use a technology that creates an intermediate model called controller. Actually, I have a movie in English that just shows exactly the difference and how this unified views and section work, because they were implemented in 2019. But there was a problem with the grid system. So now, just for you to know how to use, because most of the time we are starting from a grid system. When you create the grid system with the new functions that you find here at the basic module, axis grid, these kind of grids will only appear if you use the unified views and sections. So unified views and sections are the sections that are generated with the first module. So first submodule here allows you to create unified views and section, which means that if you create a view with like this, you can lower the grid system. So another innovative thing is that before you couldn't do this with the classical grid system, because they were looking for architectural elements. So if you wanted on the elevations to lower the axis, you could only do if you had architectural walls or columns. Now, this new grid system a bit forces you to work with the unified views and section system. So this is how they go around. So as design office, you'll have to decide whether you are using the unified views and section, or the first module, or the classical ones, which are called reinforcement. But you need to make the decision before you start the project, because you cannot switch later. So there are some special links that are created that they don't allow you to use both technologies. So what I want you to keep in mind is, if you want to first to get accustomed with the associative views and section, you just follow the tutorial I'm sending you, and you test a bit to see if it's the correct workflow for you. So if you want to use this grid system to be able to lower it in the elevation views, you can only combine this one, axis grid, with the new system of associative views and section. Now, if you want to stay with the old associative views, which now is called reinforcement drawing, you'll need to look for this button. So this button with grid is hidden, this 2D axis grid, and it can be found if you go to custom user interface, and you'll have to look for more tools with icon, and you'll have to browse it here. It's 2D grid axis, and you simply drag and drop it here in order to have the old system, which is correlated with the associative views and section. Okay, so this is just about some innovation with the grid system. It's no big deal, but usually this was very frustrating for initial planning, because you first start with the grid system, and if that is not friendly enough, you might abandon the journey. Now, another small thing, and then we'll focus on the real deal. On columns, sometimes architect demanded to have some simple chamfers, and you have some very limited shapes, or you have the alternative of creating a 2D item, import it in the library, and then assign it to the column. Now you have the possibility of creating a radius, so you can just impose here a certain radius, and you change the column like that. You can also have chamfers instead of radius. So the idea is that you can easily make fast changes. The old workflow implied you working with creating the shape in 2D and then saving in the library, loading it. Any small changes meant a lot of work recreating the 2D, saving the library and loading. So somehow they just did this, and I think it's a good thing. And now they improved also the stair modelers, which can be also used in the precast. So just to show you a bit presentation of how the new modeler looks, it's an additional thing. So you have here different shapes. Before, in 2019, they were a bit more limited, but now you have multiple shapes, and you'll see how intuitive they actually work to adapt. So of course, when you have multiple levels, multiple stories, we need to be able to model it really fast. And the old modeler, which is still available, wasn't taken out, implied a lot of settings, while now with the new one, you have everything within the palette. So it's very simple to create a double helix, radial staircase, and insert different landings and things like that, everything within the parameters. So this is an additional thing. They did not replace the old modeler, but brought this. Okay, so this is just for concept. And also the modifications now are very easily done through parameters. So you first have to input or draw the shape. You start from something, and then you can easily adapt within the handles. And another nice thing for engineers, at least, is the fact that they have implemented the architectural rules. So the proposal for the angles of stairs, dimensions, and things like that are within the palette. And you see everything is grouped and more intuitive now, friendlier, even if you include the threads and finishes. This is what they've done. And now let's see exactly how easy we can work with it. So within Allplan, we can make now a simple straight stair, but you see everything is within a single palette. So we have the 3 windows in which we work. We just start from one door and we want to get on top of that balcony. So we can start drawing in plane and then continue in elevation, as you know. But what we can do, we just establish the height difference, how we want to get there. And there's the rule for dimensioning the different parts of the geometry. We choose the structure type, and then we can easily make some offsets. So with this visual guides, it's quite intuitive what we are changing. So you have a picture that indicates by number and shows you how we are doing. But you see, we need to make some landing on top of it. We cannot just respecting a certain height of the stairs. It's quite difficult to get there without getting into conflicts with other items. So we can calibrate now the height of thread, the width of the threads, and establish what is the best solution to get to that stair. But you see, no real clicks are done, so we don't model the stair and redo it. We just preview it. And another key aspect is not hitting the roof or any obstacles. So we can generate here this portion, which is the clearance height. So this is an architectural rule. So when somebody is climbing, I think the standard is 180 height, there's no collision within the items. And also you see we can nicely insert landings, intermediate landings within the setting. So we just insert a landing and we say after how many steps we get the landing. And this pink preview is just the clearance, so that we are sure we don't hit any beams and no collision will happen between the structure and the head of the client. So everything is very friendly and stays parametric. So meaning that you start with something and then you can easily make some modification in any view. So if you look in elevation, you have some handles. In plan, you have different handles, and you can also fine-tune the representation, the attributes, the material. So this is something meant to simplify a lot. So modeling stairs usually is a challenge. You see how intuitive you can control each point of the connection. So everything is within a palette. You don't have to open as so many masks. And you know that frustrating small tip at the end starting of the stair, now it can be solved through the parameters. So you can chop off that tip so that you don't have to explode into 3D or things like that. The stair remains parametric, but also volume wise and for drawings you have incredible precision. And of course you can easily replace the side beams with some ramp, some slab and things like that, and create different favorites. So you can have your own favorites and adapt it through the project. So things that would have cost a lot of time, this can be made of timber or steel or concrete. Now it's quite easy, and also detailing wise, you see we get numbering of threads and a small description of the stair itself. But the main advantage is that now the stair is so flexible, you don't need to explode it in 3D, convert it, make modifications, and then start over if height change or things like that. Also assigning textures, it's no real challenge. And this is what we can do. So it's just one addition, this stair modeler, and you can do most of the stairs now with this version. There was another issue that somehow related to Allplan architecture, which was the roof. Roof sometimes was very complicated to do, especially for civil buildings. For precast, usually we rely a lot on 3D modeling, but at the same time, the advantage of having a roof structure is that elements will take slopes. So if we model the roof easily and then assign structural elements that are made with architectural functions, they will always align to those slopes and to the roof. So the new concept here is more flexible. You just have to draw in plane the shape of the roof, and then you establish how you want this roof to be. So you establish a pitch, an inclination, an angle, and it's a bit easier than it was before, where you had to impose a lot of dimensions in plane. So it's a bit more intuitive, and it's designed to make architects' life easier. But also for us engineers, if we have to make a small timber structure, it will help. And we can also have negative slopes for draining waters, and this can be also used within a floor. So it's not necessarily a rule to use it for roof, but also for floors. If we want to guide the drainage, it can be a solution with negative slopes. And it stays parametric, so you can change your mind at any time. And the advantage of working with such a roof is that if you use architectural elements, then for each roof you can make adjustments that modify the whole structure. And another thing is that they allow you to make multiple roofs within the same drawing and without affecting anything. So there's a roof on top of another roof, which was a limitation of the previous module, which implied working on different drawings for the same thing. So for a roof, you would have needed as many roofs, the drawings matching the number of the roofs. So it's meant to simplify, and this is the new thread of Allplan, to keep everything parametric within the tab. So you have a tab that holds all the settings instead of going through all those masks and things like that. And for complex shapes as well, there is a very powerful concept now of reference surfaces, which means that you can have any 3D model and you assign it to the architecture. So let's show exactly how this roof works, or how it can be used in our typical engineering workflows. So the idea of making a roof is to control the way a structure behaves. Architectural elements, if you have defined them with relative coordinates, they will always stick to a reference surface. In this case, the roof is a plane surface, and everything sticks to it with a certain offset we can impose. So this means that we can control the heights and slopes of different portions of a building just through these parameters. We also see here some steel elements, which is also an innovation in Allplan 2020. We'll get into more details just in a few moments. So you see how easy we can adjust the slope of already defined roof surface, but as you've seen in the previous movie, it's just about matching it in the plane, selecting a start height, and also in inverted slopes. You see here that there's an element that can be defined through two roofs. So there is a roof with negative slope, one with positive, and you can have a structural element that is adapting in between those roofs. So for the typical problems that comes with architecture with the client that changes its mind, if all these items are defined with relative coordinates, then they can adapt to this modification. So you can change whole buildings. Now, as you know, Allplan is going through an adaptation phase. They are going from formwork finder components, they're replacing them with Python parts. So most engineers loved formwork finder because there was quite a nice database that brought engineering details. They adapted to the section and started with already placing bars at different settings of placement and diameters. The disadvantage of that FF component was the fact that once you place those bars, they were like manual reinforcement. You cannot go back. You have to either delete it and apply it again or manually modify each placement. So this is the reason why they decided to migrate those powerful tools of formwork finder components with Python parts. Unfortunately, this process took more than expected, so they started replacing in 2019 some of the most used parts and recoded them as Python parts. So what is the advantage of Python part? If with Python part, everything remains parametric. So you can choose a certain detail you'd like to apply. It will adapt to the formwork and it will stay adaptive. So if you modify the formwork, you just have to access the Python and just pull the handles, but it will change everything. So it will change the longitudinal bars, the stirrups. You find them now, these components, you find them in the default, in the engineering part, in the library, and you have a lot of options. If you are run at any point out of options, you want a certain detail, it's no problem. You can use whatever you can from this part and then manually make the changes. But the advantage is that this small yellow box that stays within the column, which means that you can access this tab you find on the left, this palette. You can access it at any time and control zones. So for instance, here we can have up to 3 zones of placing stirrups, also for foundations, and everything is parametric. And it's very nice because you can use this, you can establish a typical detail, save it as favorite, and adapt it throughout other projects. So it's a great start compared to the workflow where you make a bar, you place it, make another bar, think of the concrete cover and things like that. And for the modifications, because you can start with a detail, and for other elements within the same structure, you can just vary diameter, spacing, and things like that to get really productive. So it's a great way to have this parametric, and this is something that most users are pushing. They want parametric reinforcement, but at the same time we need flexibility. So it's not yet adapting to the formwork automatically. Initially it does. If you change the formwork, however, it doesn't. You have to change this shape to rematch the formwork. But again, it's better than going reinforcement by reinforcement. Now there is another tool, copy along path. So before, this copy along path was a bit limited. First of all, the path could only be a 2D line or spline or circle. And the second limitation was that there was no link on the Z part. So if you are doing if you are designing a bridge, or you are just having a ramp and you needed to place items on that ramp along the edge of it, it was very complicated. You could only make a projection in 2D, and then you had to manually rise item by item. Um, Now with Allplan 2020, they invented another copy along any path. So this is a very powerful tool because you don't really need a path. You can just follow the edge of a 3D item. So that's just a metal bearing, and you can choose the path, and this is parametric as well, so you can change your mind even later for displacement, and you can preview it. So you can either establish an offset to start from a certain distance, or for ends you can make some clearance not to end in some point, and you can impose either a fixed number of elements at a certain distance, or just cover with a fixed amount of items. So this helps a lot, because just imagine how much time it would take to place every 5 meters on this curved shape, which varies also in the longitudinal profile, to place items on it. So if you are dealing with curved areas of a structure, or just this can happen on a ramp and you need to position some steel objects or concrete objects also, this is a very nice way to do it. So it's very friendly, and you can change your mind even graphically. So you can have this array of 10 items and just reposition them along some items. It saves a lot of time, as you don't need even to create the 3D line. You just pick up the edge and you start working with it, and same concept can apply here. So this is a sound barrier that we see attached to a retaining wall, and now we can follow the terrain line to place this inclined column. And of course we establish the count of items, offsets, and there are some rules. And the preview is also wonderful that you have it, because before you were just asked questions, dimensions, make some clicks, then you saw the results. Now with preview you are in full control of what's going on, and you see how nice it fits with the barrier, because it's just following the slope of the terrain. So it was indicated a 3D line, which was only an edge of the terrain, and also rotation can be controlled. So it's quite powerful. Maybe you are doing stadiums have a lot of precast elements, so for more complex shapes it's very useful to have this kind of placement. And I really personally like this innovation, because the alternative was really complicated. The alternative was always making on Z some modifications, and for bridges and ramps, this is something that was needed to be done. Now going forward, we have now the new offset planes. Usually when we start teaching Allplan, people get afraid of the building structure and think that that is so complicated and you have to open so many masks, you get very far from the drawing. What they started even with Allplan 2019 was to make some offset planes that are within the palette, so you can control your building structure, or actually the building structure itself can be found in the palette. So if I just open just a project to show you, you'll see that you have all the modification within a palette. So just to illustrate here better, you have here offset planes, and you can make modification on the offset planes. So now you can actually preview the offset planes, which usually was very hard to explain to beginners in Allplan, or to those who don't use relative coordinates. But these offset planes can be seen. So you have the standard planes in blue, and the yellow ones are offsetted planes. What does it mean, offsetted planes? It means that you have a plane at a certain distance parallel to a standard plane. So for instance, if you want to control the window sill, you can make an offset plane. You can have 90 centimeters, and then the window starts. And then if architect changes his mind, you just have to change only in one area this offsetted plane, and the references update. So the idea is that sometimes it's not enough to have the top floor, bottom floor, the coordinate of each floor, but you would need some reference line so that you can control easily the geometry, especially when it comes to modifications. So for complex architecture as well, where you have some items higher than others within the same floor, this is an excellent solution. And as you see here, everything is within a palette. So you go to the planes tab, you don't need to double left click on the screen and go to the modification manager of the heights and things like that. You see in real time, even graphically, what's going on with the building structure. So this is a nice feature because it encourages a lot for architects to control what they see. And also they can move it physically. You can move it by handles in the front view. And another feature with objects, you can now isolate objects and not only hide objects or drawings. You have a lot of criteria filtering, but you can generate transparencies. So you don't affect the model. You can keep the model with the textures from the architect, but you have that box which allows you to create a certain level of transparency to the items. Now for just a small thing with panorama renderings, because now VR is getting more and more popular, you have it integrated within Allplan, which means that you can actually make even movies of it. You can make a path and then you can pause and the client can look around. So it's actually a 360 movie generated within Allplan that allows you to create a path and then you pause and you explore. It's not yet moving, so you don't have a controller to move, but it's very easy to create this 360 movie or picture, and the picture itself is can be posted on Facebook or Instagram. So this platform that allow you to visualize 3D pictures, or other software can also. You get an unfolding in the rendering directly from Allplan. And another direction is with visual scripting that is more and more popular and very demanded because everybody likes to have parameters and make organic shapes, but everybody is running away from writing scripts and codes. So visual scripting is a very friendly way meant for architects or people who are thinking parametrically but not necessarily know any programming language or they don't have programming knowledge. They just can think in a parametric way of dependencies, and this is where Allplan brought the visual scripting. So it's a sort of grasshopper, only that is dedicated for Allplan and it's integrated within Allplan. So it's in the engineering package and the architectural package, and you have access to all the possible functions of Allplan with all the input and output results that can be linked within. So I'll just show you a bit how this works. So it's an alternative to programming because you don't need to make any scripts. You have only the logic of Allplan functions and you need to link with the input and output. So you have the functions and then you just create this box with different tools and modification. So it's a way of linking function, and the end result of that parametric modeling is actually Python part. So the result of the visual scripting is a Python part that has some attributes that have been agreed in this phase, and those attributes can be used. So what you see in there, it's like it opens in a different window, those boxes, you create some links, and then in Allplan you can visualize the result. So you create a box that has some parameters, some chamferings and things like that, and that's all you get. There's no line of code written. And the good thing, actually this was launched as a technical preview with 2019, but they realized that they cannot throw this to the public unless they bring some examples. So reinforcement is also allowed, and it can also be attached to different shapes. So the good thing now with visual scripting is that it has quite a large database of already made examples. So this is one example. You have access to a routine that generates sections along a building. So it can do that automatically for the user. And the possibilities are actually endless. It's just about the limitation of the imagination. because everything you can do with Allplan manually can be also done with visual scripting. So it's just some mathematical dependencies, and then you get some attributes that need to be input, and that's it. You created this reticular structure. And also different facades and organic things can be modeled, and there's no need to invest in other software. So everything is within Allplan integrated. And here I'll just open some examples to see. So you have the visual scripting, it's a button, and then if you go open, you have some examples. So this is a very basic example. It's just a table. You can pull some handles, because the visual scripting allows you to create the script. After you run the script, a Python part is generated and placed on the screen. So the visual scripting itself is in the conceptual stage, where you think of the logics and the parameters that need to be linked, but then the final result is just a Python part. And people can start working on that Python part and make modifications. But the Python part did not require any programming knowledge, as opposed to other Python parts. Now we have here a beam, a rectangular beam, and we can make the reinforcement. So we can go in these examples that they provide just out of the box with the installation, and you can have stirrup placement and longitudinal bar placement as well. You see here, this box only contains logical input data, such as edges, which is handpicked by the software, by the user, has to click on the edges. So, and the offset, other items like concrete cover are parameters that are also imposed. So on the left side, you see the parameters imposed. You just followed the edge. And then the second stage is the placement, and this placement can be done on 3 areas or multiple areas. And it's just reinforcement. It's Allplan reinforcement. You have no problem with schedules, or even if you cannot automate everything and need to make some particular modifications, then you can do it. So it's just like with Python parts, but the idea with Python part is that by default it's quite challenging to use it. So by default, to produce Python part, you need to know Python, which is a programming language, while with visual scripting you don't need to know it. You just need to link some requirements. What you're about to see now is how you can generate views, actually sections, along all the areas. So you can make a polygon, in this case it's a rectangle, that generates at a certain depth sections through a building. So you can also adjust here the depth of the sections, and that's it. You just ran the script, and in section 1, section 2, 3 and 4 everything is associative, and it saves a lot of time. And another feature with this new unified views and section is the fact that you can renumber them at any time. So that was also a challenge, because if you make one, delete it, you have to manually renumber. But with the new one, you can optimize the numbering, even change the rule. You can number them with letters and things like that. Also for attributes, they brought some improvements. Now you can export all the attributes into Excel, and in Excel you can add another other data, which is not really the designer part, but more for facility management, or for the contractor to make an offer, to attach prices, or maybe some deadlines and things like that. People love Excel, but the nice thing of this connection is that it's also going the other direction. So if you just install a plugin for it's a Beam Plus for Excel. In Excel you find a new add-on tab, and you connect to Beam Plus. You download the model, the IFC model. You get imported all the data of the model, start making changes, and then it synchronizes both in the Beam Plus, in the cloud platform, and in the software. So this helps a lot, because for many third parties it's easier just to handle attributes and information through an Excel. So this is something they innovated. And now some small things with the views and sections. You can change the properties, and now I'm referring to the unified views and section, which previously I called them architectural sections. You can change multiple properties of them at the same time, which was not possible in 2019. And you can also renumber them, which was always a frustration to have them in a straight order from the lower part. And now this is the most important of all, and is something that has been wanted and People wouldn't believe it would be possible. And this is the associative dimensioning. This is by far the most important innovation in Allplan, which means that now when you are creating any type of dimension, whether it's linear dimension or it's a height dimension, the dimension is linked with the vertex of the 3D model. So let me explain what this means. This means that for you as user, it's no big deal. You just have to, when you manually make a dimension line, even for 2D, you just have this small tick associative. What this associative does is it will track vertices. So points of variation on an item, which can be 2D, 3D, doesn't matter, are now followed. So there's a direct link with the vertex that that generates that object, and the value of it. So now you see that target like signal sign. It means that the offset is really demanding now because it will follow items. And now we make a change anywhere in 3D on a plane, doesn't really matter. So we change the opening, and now the dimension updates by itself. So this is something everybody wanted, because imagine for a montage plan, somebody just moves a purlin and you don't know exactly in which sections and which montage plan or even reinforcement plan there was a dimension that just said what is happening there. So for form work detailing, this is marvelous. You see here we can just make some architectural dimensioning, like the position of furniture, and as always somebody will change their mind and they will get updated. So even if this is just a proof of concept, we can make now the dimensioning in other windows as well. And now when we start making modification, and this modification can be done with all plans closed. You don't need to know where the plans are, because you are moving the physical position of an item, and the dimension line is just following the points that belong to that item. Of course, if you delete the item, the dimension line will also be deleted, which is correct. Or if you insert other vertices or change the shape of the item so that vertices disappear, the dimension line will also disappear. But imagine how much precision you get with plans, so they're no more outdated. And this works even in 2D. So even if you have just some lines, some rectangles, some small details, they are also updated, because any item is made of points, of vectors. Then if you change the position of the picture, you get instantly an update of dimension. So this is wonderful, because usually the modifications are done on 3D, and then you don't know how many plans are seeing and are affected by that modification. Okay, so for the international market, they implemented some of the requests for the US market and add some couplers. And also they made some customization for a new shortcut dialog to make it friendlier. And for Workgroup Manager, they invested. They made some improvements so that the data is pre-cached, it's running faster. So this translates to somewhere around, if I'm not mistaken, 30% increase in speed. With in-house, meaning that you are within the same LAN network, so it's a local area network, or you can work through Allplan Share. So they made some improvements just to make sure that data is reduced, the data required for updating, so that everything runs smoother for everybody. So you can feel an increase in the performance when there are multiple users handling the same project. And with IFC, they made some improvements as well within the IFC4. So now it's supporting the NURBS, meaning that the curve remains curved, it's not polygonized, which for architects is quite important to see everything curved and not that sketchy thing. Some interface with SketchUp and some updates on this format. And now there's also this UTM, which usually was quite a challenge. So the geodesy specialist engineers, they know the Earth is not flat, so they work with the curvature of the Earth. So when you get a UTM data file with describing a terrain, a bigger area of a terrain, then you can get some challenges with the conversion of the coordinates, because usually in design we just draw on a plane. But if you cover greater distances, which happens in the case of bridges, you cannot use those files because those files take in account the curvature. And now this is a seamless transition conversion. The system, when you import a file that contains this kind of coordinates, automatically adapts. You actually don't have to do anything. Yes, please just type the questions and then I will answer them. And another aspect in this direction is the point clouds. So point cloud is very related to BIM. If you want to apply BIM to an older building, you usually have to go, either you go on site and make some measurements, but that's not the best way to do it, and usually there's full of errors when you return to the office and try based on the measurements to redo the 3D model. The most modern approach is with laser scanning. So if you go with laser scanning, you can depict a lot of precise details in a very small amount of time. The problem was how you import from that device the object, the elevation itself. And for this, they allowed the importing of point clouds. So if you are allowed to import point clouds, then you can have the precise points and then redo the 3D model in a very good manner. So let's show exactly what they did. So they actually had a deal with Calypso just to take some basic functions, so some basic import functions. For more, you have to pay to Calypso to get a premium version of their software. But what you can do now is you import the data you get from an elevation. So this is a 360 picture that also contains some metadata regarding the points. So it's the result of a laser scanning. It's a laser scanner that measures clouds of points. And what you do now, you just select some reference points of interest on the picture, because the picture has the metadata behind that knows exactly the dimensions. So all you have to do is just click on pictures, what points are relevant for you to be able to draw this room, and then you can import these pictures into Allplan. So once you have the points, it's very easy to develop create the real form, and these are 3D points, not only in plane. This is what to do with the free version. You just have points and then you start building in Allplan. What you can do with the premium version of Calypso, so this is from their provider, is to just import volumes or surfaces directly. So instead of using some control points and drawing the 3D model yourself, you can also import that, which is for complex structure can be really helpful. So to get the initial 3D model, initial BIM model of an existing building, that can be a very nice workflow. Okay, so going on, some small improvements with real renderings, but just that you can control temperature of colors. And Allplan Bridge is a solution that allows you also to calculate parametric bridges. So I'm not going into details. I know your field of interest is not really the bridge, but if you have different partners, at least you'll know about this innovative solution. So the innovation is that what this team from Austria try to do, and I think they are on the correct path, is to make a single software that handles all the problems. So not only you draw the bridge across an axis, but you have it in a parametric way, meaning that instead of drawing a cross section and extruding it along the path, you just have a single cross section and some parameters that dictate the variation along the path and vertical wise. So you can control the longitudinal profile of this. So it's just an interpolation that is done mathematically. But this handles also the construction stages. So you can, based on the 3D model you did, you can make a Gantt graphic planning. So you add the component of time, which makes the BIM model 4D. So 4D is when you include the time part within the bridge. So what you see now is that if you want to change the red line or orientation of the bridge or adapt it further in the valley, have another bridge, you can easily do that. That is the advantage of parametric modeling. And for structure, they're also doing structural analysis. So you can have the bearing part defined with some options, but apart from that, you can add some just dead load items. So they are drawn, but don't have a structural role. They only provide some dead load. And then you get the forces distribution directly from Allplan. So you don't need to go to another software. So as you've seen, they try to automate some workflows with visual scripting. They were referring here that you can generate section and views along a path quite fast. They made the innovation with Allplan Bridge, but also you've seen, I think the very important part is the associative detailing, which helps a lot designers fulfill. Now they have another ambition, Allplan, and the ambition is that they want to include steel. It's a long way, and they should have started earlier. But what they did so far now is very nice from architectural point of view, at least. So they don't have yet any connections, but they can provide you quantities, and the modeling now is very friendly. So let me show you what is this all about. So it's not like it's for production yet, for producing within a factory the steel, but modeling steel now is finally friendlier, because we have a team that work for competitors, and they have very good knowledge when developing. So when we are dealing with grids, with steel is all about grids and center line. You need a center line which is in the center of the stiffness, not a volume, but a center line and a cross section that can be changed. And they imported the whole database of CA Engineer within Allplan. You just need to connect to BIM Plus, and you have access directly to CA Engineer profiles. And this means that if you use those profiles, you can get quantities directly from Allplan for the items you create. And not only quantities, but the detailing itself, it's there. So you know which profile and how to handle it. They made two functions. I'll show you, one for columns and one for beams. And the beams can also have slopes. So you can also make fast detailing like this, because these profiles that come from SIA have predefined attributes on them. So you can make really precise items, and this is an innovation, because they actually invented some new concept. They are called skeleton modeling, or frame modeling, because you only draw a line that has attached this cross section. And I'll just show you how easy we can make a steel hole now based on the new grid system. We go with, sorry, it's in Romania, we go with columns from the database. You should choose database of SIA, you impose those, but here I use the older database. You just make we start making a frame. We go now for a beam. I'll make half of it, and aside from the database that Allplan provide, you have now the the possibility of making a sloped beam, a horizontal one, or and to control the cutting of the item. So you see it can be cut vertically at the face, and then it's easy to connect to a slope. Okay, and I'll just go through it. You make it inclined, but everything is staying as a database. So you see you can change the geometry later, and everything is related to a grid and can have eccentricity. So now it's easier, at least for purlins, when you have within the structure, and for bracing as well. Making bracing was a nightmare before with previous versions. Now with the skeleton modeling, it's even easier.
If you like what's new in Allplan 2020 and would like to access a complete Allplan engineering training in English, simply follow the link in the description. The training is suited for both new Allplan users and experienced ones who would like to learn a few tricks using the new tools. There's also a promo code in the description for those who don't hesitate to decide.